All right, let's work on part 3 project, final project. So open up your data file, but hold on. Let me go open up the direction first. All the way in the bottom, we will have progress check number 3. I wanted to do this with you guys during class, but we ran out of time. So I'm gonna go over number 1 through 4 in this video using my sample. So you should have your data sample, data file ready, loaded in StatCrunch. So let's do this. So for this part of the project, we will look at the variable sleep hours, school night. So we're back to that variable. So go to StatCrunch and open up your data. And almost all of you that I checked have cleaned your data file pretty good. So you do not have any incorrectly formatted student responses for this column. So I'm going to see though, I'm gonna double check if this file that I'm working, but that's not right. What is this? Let me try again. Let me try to open this again. I'm sorry. All right. Data load from file on my computer. And I think I put this on my desktop. Sample for I don't know where this file is. I lost it already. Oh, here. So I'll upload this. Upload this data file. But you guys submitted this already on Canvas, so you can go and download it there. Okay, and I already have your files. All right, so scroll all the way to the right and let's find the variable that we're looking at this time, and that is sleep hours on school night. I'm gonna double check if there's any weird formatted numbers here by clicking on sort data ascending, and I'm gonna go down and see. Mine goes with 1, 2, 3, 3, 4. Those are all looking good, but the problematic ones will appear in the bottom. So if I scroll all the way down, yep, I see them. 1 to 7, 4 to 5, 5 to 6.5. You know what, guys? I'm gonna go ahead and just delete these. Okay, I'll just delete these. You probably don't have to anymore because I asked you guys to clean those up already. Because those will appear incorrectly on our frequency table. But I'm okay. I'm ready to start this. Okay, I'm ready to start this. So let's open up a Word document where you will put all your charts, okay, and your responses. Just a blank one that you will submit for me. Okay, and let's go and read the directions. Okay. Oh, oopsie, wrong browser. I'll just copy the whole thing, and I will put this over here. All right, number 1. This circle of death going around and round and round. Come on, Word, you can do it. Ah, there we go. So for this part of the project, we will look at the variable sleep hour, school night. Okay, we already loaded it. Which method will be most appropriate for the inferential statistics, Z-stat or T-stat? Why? You know what, I want to leave that for you to answer. I think we talked about this over 7 times already during class. When do you use Z-stat or T-stat? And how do you know? Why? What made you decide to go with Z-stat or T-stat? I'll tell you the answer. You're going to use T-stat. But I want you to explain to me why we must go with T-stat. Okay? So I'll leave that part for you. But I will show you how to construct a 95% confidence interval for mu for mean sleep hours on a school night for all students in your population in this database. Write an interpretation for the confidence interval estimate in the context of the data. So we're going to do 2 things. Make a confidence interval to estimate the mean sleep hours on school night for all these students. And we're going to write a interpretation. We're going to write an interpretation for that. So go to stat, T-stat, 1 sample. Okay, click on with data. But we do want to just use that variable called sleep hours on school night. Sleep hours on school night. Where are you? Okay. We want to make a 95% confidence interval. So that's all we have to do. Nothing else. Okay, nothing else. Just go ahead and click on compute. 95 was the default. And I do want you to copy and paste that table. Or let me see if I can copy like this and put it here. hold on. Okay, not bad, not bad. You can, you can copy and paste the output table. That's okay, but I just copied it as a text, and this looks okay too. All right, so we did create a confidence interval for mu. And now the second part is write an interpretation for the confidence interval estimate in the context of the data. Now guys, remember we did look at several of these interpretations, right? So I'm going to open up the most recent one that we looked at, 7.6. Doesn't matter. I'm just going to open up 6.2, not 6.2. We estimated population mean and so many of these examples, and all these examples we ended up interpreting the result. So I'm just going to go and copy one of the interpretation. Okay. Oh, something like this. I like that. And then I will go ahead and edit this to meet our scenario. Okay. So let's see. With 95% confidence, because that's our confidence level. You give me 1 second. These highlights are bothering me. Isn't there a button that I can press to get rid of all the formatting? Yep, there it was. So with 95% confidence, you can say, I'm going to say we can say that the population, hold on, I'll copy this. Say that, you see the part that I highlighted so far, I'm going to delete that because that is not the population parameter we are estimating in our problem. That was from the example that we did in class. We can say that the mean sleep hours on a school night for all students in my population. And I think we just went with, guys, it's been so long that we downloaded this file. The more specific that will be good. I'm just being very general here in my population. So what was my population? Did we only look at teenagers in the United States, or all age kids from the United States, or was it from the world population? I think one of you guys did a set of population so that you only looked at teenage high school girls. Okay, your populations are different. In my population, so in your example, in your work, I do want you to specify that for me. Okay, specify this for me. Don't write that down. Okay. I think most of us were going with students from the United States in this database. Okay, so that will be a good population to say. Okay, but now is between how many hours? Not days. They're not sleeping for days, right? In my number, in my output table, these are the answers. Is between 6 point, that's awkward for me to round. I'm just gonna go and say 6.9 hours, like from 7 hours-ish to not days, 7.3 hours. So that will be my confidence interval table and my interpretation with 95% confidence, or you can say I am 95% confident. Up to you. I mean, guys, there's so many different interpretations of confidence interval, but as long as you tell me the confidence level, the parameter that you are estimating, and your lower limit and upper limit with correct unit, you will get full credit. I am 95% confident that the mean sleep hour on school night for all students in my population, okay, it could be all students from the United States in this database, is between 6.9 hours and 7.3 hours, okay? All right, so that's it for number 2. And as you can see, we created a t-interval, okay? I want you to explain to me why we are doing t-stat instead of z-stat on number 1. That's going to be your work, okay? Or number 3. Oh, let's see. Both the National Sleep Foundation and the American Academy of Sleep Medicine agree that teens need about 8 hours of sleep per night. Now, guys, I think my group is, I don't know though. See, my group, I was 95% confident that they sleep for about 7 to 7.3 hours. I don't think they're sleeping enough in my group. Maybe your sample, you have some kids who get enough sleep, but I don't think my sample, my kids are not getting all that sleep, okay? Conduct a test of the null hypothesis that the average amount of sleep for all students in the census school database get on a school night is equal to 8 hours. I don't think that's gonna be possible because I think my students sleep so much less than that, according to what I found out. But hey, we'll see what the hypothesis tests tell me, but they have to give us the consistent conclusion. They have to say the same thing. Versus the alternative hypothesis. Look at what I'm highlighting. They gave us the null hypothesis. Say that the mu is equal to 8 hours for the null hypothesis. Say that the mu is equal to 8 hours, okay? Versus the alternative that the average amount of sleep on school night is not 8 hours. It's not 8 hours. This is a two-sided test, right? Because students may be sleeping more or they may be sleeping less, but I'm just trying to prove that they're not sleeping about 8 hours. So let's take a look. Let's do the hypothesis test, and we do want to use a significance level of 0.05. Now listen, I'm going to do my test. My conclusion and your conclusion may be different, okay? I may get to reject the null hypothesis. You may have to say you failed to reject. All our numbers are different, but I'm going to show you how to do the hypothesis test. And during class, in the semester, we talked about how to look at that p-value to make a conclusion, okay? So let me go and, let's follow this. It says A, state the hypothesis. Okay, let's state the hypothesis, null and an alternative hypothesis. I will start with that, and that is going to be the same for all of us, you guys. They gave that to us in wording, okay, in English. We're going to write down those hypotheses in mathematical symbols, okay? So first of all, H naught. The null hypothesis is stating that mu is Greek symbol for mu, and you should be able to just Google these symbols if you do not have a math type in your Word. That's okay. You can draw it and take a picture and put it on there. That's okay. But that's what we are assuming. The null is assuming that they get about 8 hours of sleep every night on school night. But the alternative, H sub A, is assuming that they're not getting 8 hours of sleep. So I'm going to go here and enter a symbol, does not equal to. And these are my two hypotheses. Okay, state the hypotheses. I think that's the plural version of it. All right, so we got part A done. Number 2, state the conclusion. State the conclusion and the summary of the significance test and interpret the p-value using the context of the data. I'm not there just yet. I don't even have my test done. So this time I'm going to open up StatCrunch and then I'm actually going to do the hypothesis test, okay? This is part B. So let's go open up the StatCrunch that we've been working with. And then you click on Stat, T-Stat, and some of you know exactly why we're doing T-Stat instead of Z-Stat, right? All right, click on one sample with data. And then we're working with the variable sleep hours on school night. Where are you? Okay, and we are doing a hypothesis test for mu. We're going to assume that the mean average sleep hour is 8 hours, and the alternative is just assuming no, they're not sleeping 8 hours. We don't know if it's more, we don't know if it's less. My data, my sample statistics came out to be much less. So I think I'm gonna see a statistically significant result here, but that's what you're gonna have to do to find your output table. So let's go ahead and get that output table first. Oh, I love it. I love it. And I'm gonna copy this down on my, I think I'm just gonna stick it on part B here, okay? Because I will be using it to interpret this. So let me see, I took a screenshot of this on my desktop, so I may be able to just pull it here, or you can copy and paste it here. I am loving my output table, and you know why I'm so impressed? Did you see my p-value? It is so small. It is so strong to be used as an evidence against the null hypothesis. Come on. All right, there we go. Okie dokie, let's talk about this. What's my conclusion? And listen, you and I may have different conclusion, and that all depends on our p-value. We want to state the conclusion and the summary of the significance test and interpret the p-value using the context of the data, and I'm about to do that. Okay, so look, this is my sentence, this is my work. It may be the same for you, but I'm going to say since the p-value is, okay, the p-value is what? The p-value of 0. Well, look, that's less than 0.001 is less than the significance level of 0.05. I reject the null hypothesis. I reject the null hypothesis. Okay, maybe I can stop there and then I can elaborate, okay? So whenever the p-value is smaller than the alpha level, you will reject the null hypothesis, okay? Now, that's the first sentence that I wrote. I mentioned the p-value. I compare that p-value to the significance level they gave me. And I have a conclusion. I rejected the null hypothesis. Now, that is not exactly in the context of the data yet, but that's my conclusion. And I'm going to have to actually go and interpret this more. Okay, I'm going to have to go and interpret this more. So remember, we just rejected this, okay, the null hypothesis, okay. I have statistically, I'm going to zoom in so that you guys can see what I'm typing, okay. Statistically significant evidence. Hold on, Noah. To conclude that the average amount of sleep for all students in the census at school database get on a school night is not equal to 8 hours, okay? Because that was my null hypothesis, I just rejected that null hypothesis, right? The null was assuming, hey, they get 8 hours of sleep. But my p-value came out so small, the probability of seeing such this sample statistic of 7.1 hours per night, it's so low. I don't believe that the assumption was true. I really don't think they get 8 hours of sleep per night, because if they truly do, there's no way my sample of 210 students will have a sample average of 7.1 hours, okay? So that's what's happening. And you know, you guys can be, you can talk long, you can add more, you can write sentences, you can break it down, and I will love reading your conclusion, okay, in Word, okay? Since the p-value that I got is less than the significance level of 0.05, I reject the null hypothesis. And tell me that you have statistically significant evidence if that p-value was small. I have statistically significant evidence to conclude that the average amount of sleep for all students in the census school database get on a school night is not equal to 8 hours. And for me, that sounds good. That sounds good, okay? And you know, you see, my conclusion, though, I mean, it doesn't tell me if they get more sleep or less sleep. I just concluded that they don't sleep 8 hours or about 8 hours. So what's telling us more though? Okay, I think, I mean, we did two things. Look at my confidence interval, okay? When I did my confidence interval, I was 95% confident that the average, the true average, is somewhere in between 6.9 hours and 7.3 hours. You see, this is entirely smaller than 8 hours, right? So I think confidence interval was a little more informing to me, that it tells me that the students in my sample, or, you know, not only that, but I can go ahead and make an inference about the bigger population, that these kids in this database, they get less sleep than 8 hours. And that is approximately from 6.9 to 7.3 hours. So that's the conclusion I can make. But as you can see, they came with the same conclusion. This number, this interval does not include 8 in the middle. This is entirely smaller than 8 hours. So 8 is not a probable or reasonable estimate of the true population parameter, okay? And that is what I rejected, right, in this hypothesis test. So let me go on, okay? I mean, this is a video, so I'm like, I have all this time, but I don't want to make this so long so that you stop watching. But I have part C and part D now, and number 4. All right, let me do part C now. Suppose you somehow found out that the average amount of sleep on a school night for the entire database population is 8 hours. Uh-oh. Because Noel, I just found out that the null hypothesis was actually true. See, look at this part, you guys. That underline, or that underline, no, I'm not underlining, I'm going to go ahead and highlight that part. Okay, that's not a highlighter. That part right there, in this case, we just found out, or we know, we were just told, right? And this isn't normal. I mean, who knows this number is true, right? But let's just say, somehow you found out that the entire base, I mean, these kids actually sleep at 8 hours. So what was true? The null was true. In this case, the null hypothesis is actually true, right? Right? In this case, the null hypothesis is actually true. That the true population average is 8 hours, okay? Now, what did I just do above? Didn't I just reject that statement? And I concluded, it's not equal to 8 hours. So, if what they are saying is true, did I just make a correct decision or an error? I just made an error, right? So, because my p-value was less than 0.05, I rejected the null hypothesis in part B. That's what I did, right? Now, this is an type 1 error. This is a type 1 error because I rejected a true null hypothesis, okay? So I think if you just mention that much, that is going to be enough, okay? Talk about what you did based on your p-value. Tell me the truth value of this null hypothesis based on what they are telling us to assume, okay? They were saying, they actually sleep 8 hours. I didn't know that, but I'm going to tell you now that they sleep 8 hours. And I'm going, because mommy was wrong, Noah. They actually, because I rejected that claim. Based on my p-value, I rejected that null hypothesis. But now they're telling me, hey, the null that you just rejected was true. So that's when I know that I made a type 1 error. Now, if you didn't reject, if your p-value was greater than 0.05 above, and some of you will have that answer. Some of you will have an opposite answer to mine. And then, that just happens to happen, right? Then in that case, you're going to have to conclude that you made a correct decision because you failed to reject or you accepted a true null hypothesis, and that's a good thing, okay? So all of our answers are going to be different. It's going to be 50-50, but I made a type 1 error because I rejected a true hypothesis, okay, a true null hypothesis. All right, let me go and look at part D now. Now, this time, suppose you somehow find out.
Why you missed it?
Hold on, Noah. Suppose you somehow found out that the actual average amount of sleep on a school night for the entire database population is 6 hours. Now, who's true now? Who is true now? The null was saying it's equal to 8. The alternative was saying, hey, it's not equal to 8, it's something else. But if the true number is 6, notice that the alternative is true, right? Null is false. So what this yellow highlighted, you know what, let me go ahead and highlight this in green this time, okay? What this green light highlighted sentence is talking about is that the null that we just rejected is actually false. So isn't that good? We rejected a false statement. So let's go ahead and write this down. In this case, the null hypothesis is false, okay? Because 6 is not equal to 8. 6 is not equal to 8. So what should we say? because I rejected this false null hypothesis based on my p-value of less than 0. I don't think I really need to add all that. Because I rejected this false null hypothesis in part B, okay, and the reason is because the p-value was so small, I can say that I made a correct decision this time, okay? In this case, the null hypothesis is false. Read this and see if that makes sense. Because I rejected this false null hypothesis in part B, I can say that I made a correct decision this time. So that's enough. That's good. It talks about the truth value of the null hypothesis based on the given. I am saying the null hypothesis is false, and that's going to be true for everybody. In part D, all of us just realize the null hypothesis is false. But, this may be different. I rejected it. I rejected a false hypothesis in part B. Some of you, if you got a big p-value, you probably failed to reject this false null hypothesis. In that case, guess what? You just made a top 2 error, okay? But none of you will mention type 1 error for part D. If you mention type 1 error, that's wrong, okay? Because the only way to make a mistake when you're working with a false statement is if you are accepting a false statement. If you are failing to accept a false null hypothesis. But I don't know. I feel like the more I talk, the more confusing it sounds. So I'm going to move on, okay? I'm going to move on. So compare the results from the confidence interval and the significance test. Are they the same? Why do you think is this the case? Now, in order for me to answer this, I think I want to kind of give you a little mini lecture on this. There is a Google slide that I did not get to go over. So maybe, and that, guys, I love teaching this stuff. I like this stuff a lot. But this isn't something that I want to just kind of give you the answer. I want to actually spend some time talking about it. This week's lecture is over, so next Monday's holiday. So maybe on Wednesday I can come back and add a little more to this. But then I'll extend the due date for the progress check number 3 so that we can talk about number 4 before we come back and discuss this very important question, okay? But in this video we went over number 2, 3, and 4. 2 and 3. 3 had multiple parts, okay? I do want you to answer number 1, and then we'll come back next week to talk about how two-sided hypothesis test and the confidence interval are related to answer number 4 more fully, okay? And so that's it for this video. So keep, save your file. This is something that you will be submitting for your final project, which is going to be very soon. So keep on saving your good work, and then we'll come back and talk about this very last question next week, okay?